Good day, everyone. Today, I'll be giving you a run through about nanotechnology. Okay, so nanotechnology, like genetic engineering or gene therapy, those genetically modified organisms are some or few of the controversial issues um, in the context of science and technology. But likewise, we cannot discount as well the benefits they provide to the community and the society in general. Okay, so for this topic, we're going to discuss major impacts, both potential, meaning to say possible impacts, and realized these are already present existing impacts of nanotechnology in the society, and analyze the issues through the conceptual STS lenses. Okay, so there are a lot of definitions floating online about what nanotechnology is. For the European Commission, it is a study of phenomena and fine tuning of materials at atomic, molecular, and macromolecular scales, where properties differ significantly from those at a larger scale. So products based on nanotechnology are already in use, and analysts expect um, markets to grow by hundreds of billions of euros during this decade. Okay, in other words, nanotechnology is associated with, or it might have impact with other economy. It's because of its wide range of applications, which later on we're going to explore. Okay, so another definition from Foresight Institute, it's structures, devices, and systems having novel properties and functions due to the arrangement of their atoms on the 1 to 100 nanometer scale. So many fields of endeavor contribute to nanotechnology. So nanotechnology is not just it's not an independent science. So it needs application, or it needs knowledge from other domains of science also, such as molecular physics, material science, chemistry, biology, computer science, electrical engineering, and mechanical engineering, in order to create a nanotech product. Okay, so for the National Nanotechnology Initiative, it is the understanding and control of matter at dimensions between approximately 1 to 100 nanometers, where unique phenomena enable novel applications. Encompassing nanoscale science, engineering, and technology, nanotechnology involves imaging, measuring, modeling, and manipulating matter at this length scale. Okay, so, for Thomas Thies, the Director of Physical Sciences at the IBM Watson Research Center, nanotechnology is an upcoming economic, business, and social phenomenon. Nano advocates argue it will revolutionize the way we live, work, and communicate. Okay, so in a nutshell, when we combine their definitions, we see similarities. Okay, and again, they define nanotech as structures between 1,000 or 100 nanometer in size. So to give you an idea how small that it is, it would take 800 nanometer particles side by side to match with to match the width of a human hair. So the ability to see nano-sized materials has opened up a world of possibilities in a variety of industries and scientific endeavors. Okay, so again, if we are um, to to identify, or to evaluate what is one nanometer through this diagram, through a diagram, so we can refer to figure one. We call it the scale of things. It's created by the U.S. Department of Energy. So it provides a comparison of various objects to help you begin to envision exactly how small a nanometer is. So the chart with the objects that can be seen by the unaided eye, such as an ant, which is at the top of the chart, and progress to objects about a nanometer or less in size, such as the ATP molecule used in humans to store energy from food. Okay, so again, when we look at the top, it's the ant. Okay, and that's 5 millimeter. Okay, and when we head downwards, so it's where we can see a nanometer in size. So basically, it's very 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 small. Okay, so there are different identified nanotech particles. So we have the buckyball, or commonly known as C60. It has an interesting electrical property of being very good electron acceptors, which means they accept loose electrons from other materials. We also have nanotubes. It's the one at the center, letter B. Okay, so they have the highest strength to weight ratio of any known material and are combined with other materials into composites that can be used to build lightweight spacecraft. Then we have graphene, the ones you see in the far left, far right rather. So common graphite is the material in the pencil lead, and it's composed of sheets of graphite stacked together. Okay, so these are some of its application. Okay, so the one is for the carbon nanotubes. What you're seeing right now is a lithium metal batteries. So this image of lithium metal anodes after 500 charge or discharge cycle in test at Rice University shows that the growth of dendrites is quenched in the anode at the left, protected by a film of carbon nanotubes. So the unprotected lithium metal anode at right shows evidence of dendrite growth, and this step may help develop lithium metal batteries, which could have much higher capacity and faster charging than lithium ion batteries. So again, what we with these lithium batteries, so it's very prone to the growth of dendrites, and we don't want that to happen, because that means to say sooner or later the battery will lose its efficiency. Okay, but when comparing that one with the image on the far left, on the right rather, on the left rather, not far left, because there are only two images on the left. So we can see that the growth of dendrite is restricted, and so this would mean that the battery would have longer lifespan. Then we also have the researchers at Texas Heart Institute and Rice University, which have confirmed flexible conductive fibers made of carbon nanotubes. So again, remember that carbon nanotubes are good acceptors of electrons. So with this technology, the flexible conductive fibers, which is made of carbon nanotubes, it can bridge damaged tissues to deliver electrical signals and keep our hearts beating despite congestive heart failure or air-related cardiomyopathy or after a heart attack. So it's sort of like a band-aid, which is put into there. But the difference is that band-aid is used to cover, but this one it is used to bridge, or yeah, it is used to bridge damaged tissues in a way that still electrical signals will be transferred, let's say from one neuron to another. Okay, so um, we also have this one, the spongy blocks of carbon nanotubes, which is created by Mauricio Tenoris and his colleagues. So it has an outstanding ability to absorb oil, separating it from seawater. So the new material, which could be used to clean up oil spills in oceans, also have other novel applications related to electronics, material science, and medicine. Then we have this one. It's a non-invasive skin patch made from thin film graphene. So it measures glucose levels without the need for a prick blood test, because for diabetes patients, they normally have to do this finger prick blood test. Um, and I don't know if some of you are familiar with this one, but it's called invasive because, of course, the patient has to be wounded. Okay, but with this non-invasive, invasive skin patch made from thin graphene, so there will it will not involve anymore like the collection of blood sample. So this device works by drawing out glucose from the fluid between across hair follicles, which are individually accessed via a miniaturized pixel array platform using a small electric current in a process called electroosmotic extraction. Okay, so we also have this one, the low cost water distillation. So water, in fact, can penetrate these sub-nanometer size pores, white salt ions, larger than water molecules, cannot, and because of the ultra low thickness of the membrane. So NPG was predicted to have greater water permeability coefficients than current thin films composites or RO membranes. Okay, so next one we have, that's for graphene, we have nanocomposites. So this one speeds up the healing process of broken bones. So researchers have shown that growth of replacement bone is speeded up when a nanotube polymer composite is placed as a kind of scaffold which guides growth of replacement bone. So the researchers are conducting studies to better understand how these nanocomposite increases bone growth. Then we also have these nanoparticles recently used to detect or to evaluate or to diagnose if one is COVID infected or is infected by COVID. So researchers at the University of Maryland are using gold nanoparticles to develop a quick diagnostic test for COVID-19. So a nasal swab containing a test sample is mixed with a simple lab test. It contains a liquid mixed with gold nanoparticles attached to a molecule that binds to the novel coronavirus. So if the virus is present, the gold nanoparticles turns the solution a deep blue color and a precipitation is noticed. So if not, the solution retains its original purple color. So here in the in the diagram, if it is if a certain patient is positive, so again, precipitate will settle down at the bottom. Then on the left, the color will be retained if it is negative or if the patient is negative. Okay, so we also have another application of nanoparticles. Researchers are reporting results from a clinical study using gold silica nanoshells heated by near infrared lasers to destroy tumors in prostate cancer patients. Okay, so um, next one we have the photocatalytic copper tungsten oxide nanoparticles. It is used to break down oil into biodegradable compounds. So nanoparticles agreed that provides high surface area for the reaction. So it is activated by sunlight and can work in water, making them useful for cleaning up oil spills. That's its application. That application is for the environment. Okay, so we also have the wearable blood purification system, um, and a zeolite polymer composite and nanofiber mesh. So the this in letter C is a nanofiber with the nanofiber is composed of blood compatible polyethylene covinyl alcohol as the primary matrix polymer and zeolites, which are capable of selectively absorbing uremic toxins. So researchers believe that these nanofiber can be used in compact and an expensive blood purification system as an alternative to dialysis. Okay, then we also have this one, again, on the application of nanofiber. So researchers have developed piezoelectric nanofibers that are flexible enough to be woven into clothing. So the fibers can turn normal motion into electricity to power your cell phone and other mobile electronic devices. Then we also have this one, the sensor using zinc oxide nanowired detection elements. So capable of detecting a range of chemical vapors. So that is schematic illustration of acetone sensing mechanism. So, and we also have the quantum dots. So researchers at the University of Colorado Boulder are investigating the use of quantum dots to treat antibiotic resistant infections. So these antibiotic-resistant bacteria, such as Salmonella, E. coli, and Staphylococcus, infect some 2 million people each year. So efforts to thwart these so-called superbugs have consequently or consistently fallen short due to bacteria's ability to rapidly adapt and develop immunity to common antibiotics such as penicillin. So this is what I said in previous discussions that some bacteria are now drug resistant, so whatever some medicines or some antibacterial drugs before might no longer work. So That's why nanotechs are coming into place to fix this problem. Okay, so we also have we also have another application of quantum dots. So these provide higher peak brightness, wide color, what's this wide color gamut. I don't know. This is a familiar term, and better image quality display. So, displays using quantum dots should be thinner, lower power than current displays, as well as able to be flexible. So, these are crucial requirements for best Ultra HDR experience. So, there's are some questions concerning nanotech. So, if nanotech help us to live longer or produce manufactured goods from inexpensive raw materials, what is the moral imperative about making such benefits available to all? So, again, it speaks here of the gap between the rich and the poor, because it's only the rich. These rich people will only have the access for these for these materials or for these technology. So, is there is sufficient understanding or regulation of nanotech-based materials to avoid harming people or our environment? So, we don't have, especially here in the Philippines, we don't have here. We don't have policies. I mean, solid or firm laws and policies regarding this one. So, regarding nanotechs, how could molecular manufacturing have an impact on our global economy, and what would happen if nanomedicine made it possible for us to halt aging by making repairs at the cellular level? So, we can what's that? We can defy aging. Um, all will have a longer lifespan, and that would have an impact to to the economy and even to food security, because every day there will always be birth rate, but mortality rate is will be will be very low. Okay, so next, if everybody could live hundreds of years, what would happen to our economy and society? Would only an elite few get such treatment, and what consequences would that have? So if nobody ever died, would people have to stop having children to avoid overpopulation? Okay, so that ends my presentation, and this is your task. Select one news article regarding a scientific breakthrough in the use of nanotech in any field: environment, example, environment, electronics, healthcare, energy, space, flight, and etc., and among others. So make sure that you will not repeat any of those presented a while ago, and carefully analyze the potential benefits, realized, and potential hazards of this breakthrough in the society. So you present your analysis in a tabular format. That ends my presentation, and thank you for listening. Goodbye.